Slide number 8. Develop. Triangle area formula. Directions. Answer the questions below in the gray boxes. Refer to the figures below when answering the questions. We have figure A, a parallelogram with height h and base b. Figure B, two triangles with both the same height h and the same base b. Number 1. Describe how you can find the area of a parallelogram. To find the area of a parallelogram, you blank. What has been the formula that we've been using this entire week? We multiplied two things together to get the area of a parallelogram. What were those two things? Number 2. A parallelogram can be decomposed into two identical triangles by drawing a diagonal line. How can you know that the two triangles are identical? Let's look at figure 2, or figure B. If I smush these two triangles together, I wind up with a parallelogram that looks exactly like figure A. Notice this line going from the top corner all the way down to the bottom corner, and it's diagonal. That line is cutting it right here in figure B, so we have our two triangles. Now, we're taking a parallelogram, we're decomposing it or cutting it, breaking it apart to get two identical triangles. How do we know they're identical? What do you see in your picture that tells you that they're identical or exactly the same? That's number 2. Number 3. How are the areas of the parallelogram and triangles related? Let's think. We started off with a parallelogram here. We cut it in half to get our two triangles. How do you think the areas are related? If the area of a parallelogram is base times height, now my triangle is half of that parallelogram. What do you think the area of a triangle might be? Number 4. Describe how you could use the formula for the area of a parallelogram to find the area of one of the triangles. So again, just like number 3, my triangles are